Today will be a presentation for our field table discussion for Book 2. So, carrying on, this case study, this is the Thompson family, which unfortunately has about all of their sick children with the diseases. Although, where healthy parents Clark and Susan have children diagnosed with two distinct causes of recessive genetic disorders, cystic fibrosis and sickle cell anemia. Despite both parents being healthy and not showing either condition, their children, James with cystic fibrosis, Lucas with sickle cell anemia, and Sophie with highlighting the complex nature of genetic inheritance. The following analysis will explain how these disorders are transmitted from parents, why the parents remain affected, and the biological process by which DNA mutations lead to the expression of these diseases. From here, you can see the hybrid unit square, where it's the father and the mother's phenotypes that can show us how this works. And you can see the ratio, which is the 9:3:1, where the one is cystic fibrosis and SCA, which highlights how hard it is to get both conditions.
So now let's look at sickle cell anemia, or SCA. SCA is a genetic blood disorder that affects hemoglobin, the protein in red blood cells that carries oxygen around your body. So it's caused by an inherited gene mutation. A person gets sickle cell anemia only if they inherit their faulty gene from both parents. So SCA leads to anemia, causes pain, infections, and organ damage, and oxygen cannot be carried efficiently. The symptoms include chronic tiredness and weakness, pain episodes, which is called as sickle cell crisis, shortness of breath, and frequent infections and delayed growth in children. So next is cystic fibrosis, CF. So cystic fibrosis is a genetic disorder that mainly affects the lungs and digestive system by causing the body to produce abnormally thick and sticky mucus. The causes of this is by mutation in the CFTR gene, cystic fibrosis transmembrane conductance regulator. A person must inherit the faulty gene from both parents to have this disease. So the effect is blocks airways in the lungs, making breathing difficult, block pancreatic duct, and preventing digestive enzymes from reaching the intestines. The symptoms are tiredness and weakness, delayed growth in children, salty tasting skin or swell, persistent cough, often with thick mucus, difficulty digesting food, and lastly, abdominal pain or bloating.
One of the facts that we know that the spouse, Mr. Clark and Mrs. Susan, are both healthy. And for their first child, which is Joshua Clark, who is 18 years old, is healthy and shows no sign of genetic disorder. However, for his another child, James, who is 15 years old, was diagnosed with cystic fibrosis, or CF, at the age of 3 after frequent chest infection. And for Lucas, who is 12 years old, was diagnosed with sickle cell anemia, or SCA, at the age of 2. Sophie, who is 8 years old, was diagnosed with both CF and SCA within the first year of life. And both CF and SCA are confirmed to be autosomal recessive. These genetic disorders affect males and females equally due to autosomal inheritance.
So now we will talk about how the ages of how did children get the disease of the cystic fibrosis and the sickle cell anemia. Because both of the parents know disease, so they could be carriers for CF and SCA. Joshua be carried on carrying that. During reproduction, adults are passed to offspring randomly and independently. causes some children to inherit two recessive alleles. Grandparents replicates and leave the root of one. Capital child inherit copies of mutated gene from the parents. Parents don't have the disorder but probably are carrying. So, James is a homozygous recessive and the CF levels. It is not homozygous recessive, therefore, his phenotype is CF only, which is AADB. This disorder follows an autosomal recessive inheritance pattern rather than sex-linked inheritance.
So there are four learning issues that we have listed. The first one is why carry a visual procedure. The second one is why autosomal recessive disorder affect males and females equally. The third one is what type of mutation affect the abnormalities in protein. And the last one is which CFTR mutation cause misfolding versus getting defects. That's all.
So, for the action plan, our group has prepared 6 action plans. The first one, draw on the square to determine genotype probability for CF and SCS separately. Second one, carrier testing test to confirm if both parents are carrying the same mutation. And third one, review Mendelian inheritance and probability rules. And fourth one, review prior genetic test result for James if absence or incomplete order a comprehensive CFTR variant panel. And fifth one, construct dihybrid cross for both traits together. And the last one, support affected individuals with long-term medical management and regular monitoring.